All right, part two of module one has the following two objectives. The first objective that we're going to cover in this video is using tables and graphs with sequences. The goals of this objective are to be able to read a table with term position represented by just the letter N, the position is N, and sequence number, which is A sub N. We'll talk about that in a second. So just being able to look at a table of a sequence and be able to recognize the term position versus the sequence number. And then also being able to understand the difference between an arithmetic graph and a geometric graph. Just like you were able to understand the difference between the arithmetic explicit formula and the geometric explicit formula, hopefully at the end of practicing objective one, if you were to look at a graph, you'd be able to tell me, is it arithmetic or geometric? Now, as you're going through this, please consider, and I'll have this up on the board while you're working on this, but during the practice problems, the three examples or the two examples you're going to do on your own, your mastery should be 14 out of 16. Each example problem has 8 pieces, and so if you get, so there's 2, so there's 16 total. If you get 14 out of 16 pieces right on the example problems, you're doing great. Now, doing okay is 12 out of 16. If you need help, it's less than 10 out of 16. Now, there will be homework or more practice depending on what stage of this part 2 you're in or what time you're entering into this. But the homework is just 4 problems that put together all 4 pieces that go with the 2 goals up here, goals 1 and 2, and being able to draw the graphs using the explicit formula and finding a specific term. So on the homework, they each have four parts, but I just did it by problem. There's 4 problems you'll have to do. I'm setting the bar really high because I do feel that you guys can be very successful with this. Mastery will be 4 out of 4, and you can read during, or doing okay is 3 out of 4, and you need help is 2 out of 4. And then objective 2 is using sequences in real-world situations, so technically word problems. That's supposed to be world. It says word. I just screwed up the saying of it too. Using sequences in real-world situations. So when you get to this part, objective 2, there's just practice problems. Mastery is 5 out of 6, again, because they're broken into pieces. So there's 6 pieces because there's 2 problems. Doing okay is 4 out of 6, and you need help is less than 3. So you'll be able to gauge yourself. If you ever, again, find yourself in these categories, the need help categories, please find me. I'll make a note, or I'll be coming around too to make sure everyone's tracking, but please always feel free to ask questions. All right, so let's begin with objective 1, using tables and graphs with sequences. So being able to draw a table and then also being able to tell me what's the third term or where is the positioning of that. Example 1 says given the sequence 3, 6, 12, 24, and then I'm going to first use a table and then interact it with a graph. So eventually you're going to have to be able to tell me, is this arithmetic or geometric based on prior learning? And so that'll come to play in part B and part C, and eventually in D as well. But for part A, to create a table based on the sequence, it is pretty straightforward. If I was going to do this one on my own, I would draw a tallish rectangle and break it up into pieces with a labeling box on top. The labels are going to be N, which if you remember from the initial part, N is the term position. Just what position or what number is in what order. And then the A sub N is just, okay, what's the first term? The first term is this number. That's what A sub N represents. There's 1, 2, 3, 4 numbers, so I'm going to draw 4 boxes. 1, 2, 3, 4. So my first term, position 1 is 3. Position 2 is 6. Hopefully you're seeing this. All I'm doing is the first number listed is 3. The second number listed is 6. So the number in position 2 is 6. The third number listed is 12. And the fourth number listed is 24. A table will be valuable, especially for the word problems here in a little bit because it just helps you visualize the numbers in a little different way. If you're just given the sequence up here, sometimes it's hard to visualize them. So that's why a table is necessary, and you need to be able to do that. From there, you need to graph it. So like we talked about with functions, you can consider this, the n, to be the input. So I'm going to write input up here. Please write input, which means the a sub n is the output, or the outputs, I guess. Hopefully you remember the input is the x variable, the output is the y variable. So we're just going to draw this on our graph. Inputs and then plotting points of the inputs and outputs. So the first one is 1, 3 is the first coordinate point. So I'm going to go over to 1 on my graph up to roughly 3, which is right about there. Next 2 points are 2, 6. Over to 2 up to 6, which is a little above my hash mark of 5, so right there. Next one after that is 3, 12. Over to 3 up to 12, right about there. And then 4, 24, over to 4 up to 24. And then I'm just going to, it starts at the origin, 0, 0. I'm just going to connect the dots as nice as I can. And it'll continue going up like so, roughly. We could try to find the fifth, but we don't necessarily need to. I think 4 coordinate points give us enough information about this graph. So I've done part A and I've done part B. You will need to reproduce this part A and part B when you practice on your own. Now, for the explicit formula, let me move the screen down a little bit and then erase some little dots here. The explicit formula that's practiced from yesterday, or prior part 1 of this, wherever you find yourself, you need to remember there's 2 types of explicit formulas. There's an arithmetic explicit formula and geometric explicit formula. The explicit formula, to me, if I was going to do this, would be determined by, is there a common difference or a common ratio? So if I go back to my table, this is very important that you're able to see this. The difference occurs in the a sub n terms. So remember, to find the difference, I can do 6 minus 3. If I want to see if it's arithmetic, 6 minus 3, the second term minus the first term, equals 3. To test to see if that works, I do the third term minus the second. 12 minus 6 equals 6. These 2 numbers are not the same, so it is not arithmetic. So let's try geometric, seeing if they multiply. Go up by a multiplication factor. So let's try 6 divided by 3. 6 divided by 3 is 2. 12 divided by 6 is also 2. So the common difference between 3 and 6, you multiply by 2. Between 6 and 12, you multiply by 2. Between 12 and 24, you multiply by 2. So I have found a common ratio in this case, and it is in fact geometric because of the r equals 2. If it was a common difference, then it's arithmetic, but in this case it's geometric. So I needed to do some math, but this was prior knowledge, all of this stuff, in order to find the explicit formula for the sequence. Now I'm going to write down, and it's important at this point, you can look back in your notes if you don't remember, but the default explicit formula for a geometric sequence is a sub n equals a sub 1 times r raised to the n minus 1. Now if you remember from part 1's learning, the only 2 things that change are the a sub 1 and the r. They become unique to each sequence. So I'm going to write its specific formula, I'll do it in green next to it. A sub n equals, a sub 1 is just the first term, I can look up here. A sub 1, the first term is 3. So equals 3 times, my r, we just did the math and found it to be positive 2, times 2 raised to the n minus 1. That is the explicit formula for part C. And then we just answered that question. Is this arithmetic or geometric? It has to be geometric, and the reasoning behind it is that geometric because it has a common ratio of 2, meaning it's being multiplied each time, not added or subtracted. Each time. So, I answered all of the options, A, B, C, and D. You have 2 problems now to try, 2 more examples to try that look similar to this, that test your knowledge of being able to create a table, part A, graphing the sequence, part B, writing the explicit formula, and then describing to me whether it's arithmetic or geometric. Now, it's important to note there's one more possibility that exists. I mean, I can also tell just by the picture of the graph here if it's arithmetic or geometric. There will be an example problem that you solve that is arithmetic, and when you get to that point, you need to raise your hand and be able to discuss with me the difference of the graph between a geometric, which we just graphed, and an arithmetic that you'll eventually graph when you get to that problem. Because they are different and they are unique, and that will be a jump-off point too for you to be able to tell the difference between the two. Go ahead and try example 2 and example 3 in your packet now.